For this lesson, what we're going to be talking about is going from scientific notation and then writing it in standard notation. So to start off with, just a couple of refresher rules. So again, if the exponent on your number is positive, then we're going to move our decimal point to the right so that our final number is bigger than 1. You remember, if you have numbers, I'll just run through an example right now. So if I have 1 times 10 to the second, this number should be bigger than 1 because our exponent is positive. So we go to look at this. So my number is 1.0. Now, the 2 tells us the number of times to move, number of movements. We're basically working backwards from the steps of writing standard notation into scientific. So 1, 2. So then we just fill in the zeros. So that means that's our number. Our number is 100. If I had 1 times 10 to the 4th, then it would be 1, and there's my decimal point. So 1, 2, 3, 4. And I would just fill in all of my zeros. So my answer would be 10,000. So you don't have to fill in, you don't have to put in a decimal point at the end. If your exponent is negative, then that's going to tell us that we need to move to the left. We need to move the other way so that our final number, that should be smaller. Smaller than 1. So for example, if I had 1 times 10 to the negative second, and I'm going to convert this. So this is what our number starts off with. So I need to move it 2 times to the, I need to remember not hold that, 2 times to the left. So 1, 2. So that's where our new decimal point is. We need to put a 0. So our number becomes 0.01. You could include the other 0. You do not have to. Again, I do 1 times 10 to the negative 5th. Then that becomes, so this is 1.0. So 1, 2, 3, 4, 5. We fill in all of our zeros. So we got 4 zeros there. Please always make sure to put a 0 out in front of your decimal point. Sometimes decimal points get lost, and so I'm going to just always assume that you're doing a leading 0 there. Let's run through a couple of examples. I'll give you the examples, allow you time to pause it, and try converting back. So let me just scribble some of these down. So let's do 7.3 times 10 to the 4th. 8.97 times 10 to the negative 3rd. 6.01 times 10 to the 8th. And 6.2 times 10 to the negative 7. So at this point, if you need to, go ahead and pause it. Or if you want to, go ahead and pause it, try working them out, and then you can check yourself. Okay. So for this first one, what our number should be is 7, 3, and our decimal place is 4 times. So 1, 2, 3, 4. So we end up with 1, 2, 3 zeros afterwards. 3 zeros, and then I'm going to throw my comma in there. So there's that. With the next one, so we're going to move it 3 places to the left. So 1, 2, 3. So we end up with 2 zeros in behind our decimal place, but remember you need 1 placeholder out in front. Next one, we're going to end up moving it 8 times. So there's 1, 2, 3, 4, 5, 6, 7, 8. And then now this last one, 1, 2, 3, 4, 5, 6, and 1 more. So 7, and then 2. So one thing I want to point out with this last one, so just to kind of show you what I did there. I always know if it's a negative exponent moving to the left and it's already written in correct standard notation. You've got to move it at least once to get past that first one, and then all of the rest are zeros. So like with this one, I know that 6 of these are going to be zeros with one number. So I can very quickly write these out, and then I know 1, 2, 3, 4, 5, 6, and that finishes out all of our movements there. So same with, let's say I had a number, 1.0, just to make this easy, times 10 to the negative 8. I know it's going to be 0.7 zeros and then 1. I already know it's going to be 1, 2, 3, 4, 5, 6, 7, 8. Just kind of as a quick shorthand with those. Doesn't necessarily work with positive numbers because it just depends on how many non-zero numbers are past the decimal point.